सो हेलो गाइस, इस लेक्चर में स्टार्ट करते हैं अपना कॉमन एमीटर कॉन्फ़िगरेशन। ठीक है, कॉमन एमीटर कॉन्फ़िगरेशन। ठीक है, सबसे पहले पॉइंट में हम लोग उसका डायग्राम देखते हैं और जो डेफिनीशन है रिलेटेड और वो देखते हैं। ठीक है, सो इन दिस कॉन्फ़िगरेशन emitter is common between input and output. So input is applied between base and emitter, and output is taken across emitter and collector। ठीक है, डायग्राम को देखते हैं पहले तो। सो ये रहा एक आपका एनपीएन ट्रांजिस्टर, इसमें ये बेस है, ये रहा emitter and this is your collector. Now emitter is common, clear? Now there will be a diode at the emitter side, emitter base junction side. Now this should be forward biased, ठीक है? So plus minus. Now if we see the input is what? VBE comma IB. So this is your input parameter. Now output is taken across the collector and emitter. So it is this is your VCC and RCC, and this is IC. So there will be IE. Okay. Now since this transistor is NPN type, so NP and now output अगर मैं देखता हूँ आउटपुट की, ये तो इनपुट पैरामीटर हो गए ना। आउटपुट की अगर हम बात करते हैं तो आउटपुट कहाँ पे होगा? आउटपुट इज टेकन अक्रॉस द VCE कॉमा IC। ठीक है, सो इन दिस कॉन्फ़िगरेशन द एमीटर इज कॉमन एंड इनपुट इज व्हाट? VBE कॉमा IB एंड आउटपुट इज व्हाट? VCE कॉमा IC। क्लियर है यहाँ तक? नाउ नेक्स्ट थिंग इज व्हाट? इफ यू सी द सैंडविच डायग्राम देन इट इज NPN. So it is emitter, this is your collector, and this is your base. So emitter base junction should be forward bias, so it is forward bias. So this should be IB, then this should be your IC. So both are in, then out IE should be out. Is it okay with you? So this is the sandwich diagram and this is symbol representation of a NPN transistor in case of common emitter configuration. Now second point में देखते हैं हम लोग कैरेक्टरिस्टिक। नाउ कैरेक्टरिस्टिक को समझने से पहले हम लोग देखते हैं अर्ली इफेक्ट। और कैरेक्टरिस्टिक भी दो टाइप की थी अगर आपको याद हो, इनपुट कैरेक्टरिस्टिक एंड आउटपुट कैरेक्टरिस्टिक। ठीक है, नाउ सबसे पहले मैं इनपुट कैरेक्टरिस्टिक को समझाने के लिए क्या करता हूं, आई जस्ट चूज द अर्ली इफेक्ट ऑल्सो। ठीक है, सो सबसे पहले अगर मैं इनपुट को ड्रॉ करता हूं, इनपुट कैरेक्टरिस्टिक को, इनपुट कैरेक्टरिस्टिक। नाउ इट इज अ कर्व ड्रॉन बिटवीन the input voltage and input current. So input voltage is VBE and input current is IB for constant output. So it is a curve drawn between the VBE versus IB for constant VCE. This is the definition of input characteristic. Now if you plot this input characteristic, so it is what? VBE and this is what? IB. Now since the diode is forward bias, so this curve is similar to diode forward bias curve. ठीक है यहाँ तक, because diode is on, anode is positive, cathode is negative. Now suppose this characteristic is now this. Is it okay with you? क्लियर है यहाँ तक? नाउ वी सी द इफेक्ट ऑफ VCE. नाउ इफेक्ट ऑफ VCE, ठीक है यहाँ तक. Now VCE is equals to what? VCE is equals to VCB plus BBE. Now from that VCB equals to VCE minus BBE. Now BB is constant. BB is constant. Then if you increase the VCE, then VCB increases. Now as the collector base voltage increases or VCE increases, then the effective base width, then so as VCB increases, effective base width decreases, recombination in the base decreases, so IB decreases, but IC increases. This time IC increases, so gain is what? Beta in this time. IC, because output is IC and input is IB. So IB decreases, beta decreases, no doubt beta is increases, but IC is also increases, so beta increases very fast. Beta increases very fast, and alpha is also increases, so alpha beta both are increases. In case of common emitter configuration, the early effect or the base with modulation decreases IB, IB. Clear? So suppose this is for IB, sorry, this is for VCE 0. Now as VCE increases, the IB decreases. So this curve like that. So it is the VCE increases. Clear? So this is the curve representing the VCE is increasing. Clear? Now if you see the characteristic, then the slope is equals to 1 upon R of I, that is equals to IB upon BBE, or we can say the input resistance is equals to BBE upon IB. So IB decreases, RI increases. Clear hai yahan tak? RI increases. That means what is the conclusion? Conclusion is that the input resistance of common emitter configuration is greater than the input resistance or impedance of common base. Now this is of 800 value ohm and this is 100 ohm value or 10 ohm. ठीक है यहाँ तक clear है? So it is the range of 10 to 100 and it is 800. So I hope so जो इनपुट कैरेक्टरिस्टिक है वो बिल्कुल क्लियर हो गई होगी. इस पे अर्ली इफेक्ट का क्या फर्क पड़ता है, इफेक्ट होता है, वो भी आपको समझ में आ गया हो. नाउ आउटपुट कैरेक्टरिस्टिक स्टार्ट करते हैं. नाउ आउटपुट कैरेक्टरिस्टिक को समझते हैं. आउटपुट कैरेक्टरिस्टिक सेकंड पॉइंट में ही. ठीक है. सो आउटपुट कैरेक्टरिस्टिक क्या है? इट इज अ कर्व ड्रॉन बिटवीन द VCE एंड IC for constant value of IB. ठीक है. So VCE versus IC for constant IB. ठीक है. Now so we have relation is what IC is equals to alpha IE plus ICBU. Then we have also relation IE is equals to IB plus IC. I hope so. Clear है यहाँ तक? Now this is equation 1. Sorry, it is equation number 1 and this is equation number 2. Now just put second into first. ठीक है. So IC equals to alpha IB plus IC plus of ICBU. So just alpha common, then 1 minus alpha into IC equals to alpha times IB plus ICBU. Now just divide by 1 minus alpha, so it is alpha 1 minus alpha IB plus 1 upon 1 minus alpha times of ICBU. Now this factor is known as beta. I will tell you in the relation between alpha, beta and gamma. Then it is beta IB plus this relation is called 1 plus beta ICBO. Now this relation IC is equals to beta IB plus ICEO. This is the relation of IC in case of common emitter configuration. Now if you compare this relation with this is common emitter and this IC equals to alpha IE plus ICBO. Now ICEO is equals to 1 plus beta times of ICBO. Then ICEO is greater than ICBO by 1 plus beta factor times. Clear है? And we know that as alpha increases, beta increases very fast. ठीक है? So slope of common emitter curve is more as compared to common base output curve. ठीक है, यहां तक ये बात समझ में आ गई, क्योंकि यहां बीटा ज्यादा है एज कंपेयर टू अल्फा. क्लियर है? ये बात समझ में आ गई. दिस इज फॉर कॉमन बेस कॉन्फ़िगरेशन. तो जो कॉमन बेस का स्लोप है आउटपुट कैरेक्टरिस्टिक का, उस जो कॉमन बेस का कर्व है या स्लोप है, उसका स्लोप कम है एज कंपेयर टू कॉमन इमीटर. या कह सकते हैं कॉमन इमीटर जो कि आउटपुट कर्व है उसका स्लोप ज्यादा है एज कंपेयर टू द कॉमन बेस आउटपुट कैरेक्टरिस्टिक कर्व. ठीक है? सो कर्व को ड्रॉ करते हैं. नाउ दिस इज IC and this is VCE. Now when this equation, when IB is 0, the input current is 0, the IC is equals to ICEO. So this is the ICEO. Now this is your ICEO. This is greater than the common base current. This is ICEO. Now the region where we have very small current or no current, then this region is called cutoff region, where the transistor work as an open switch. Clear? Now as this current is add up to this beta IB, then we have the relation like that, the relation we have this thing. Clear? Now this is IB 0, then IB1, IB2, IB3 and IB4. So this is the representing IB increases. Now if you plot the same curve, for common base in this, then curve is like that, na? This is common base, the red one. This is for common base, the red one. This is the common base curve. Is it okay with you? So the red one is for common base and the blue one is for common emitter, the blue one is. ठीक है? So slope of common emitter is greater than slope of common base curve. Now slope is equals to 1 upon R0. So slope is higher then R0 is good. So R0 of common emitter is less than the R0 of common base. Clear है यहाँ तक? I hope so. ये बात समझ में आ गई होगी. Now the region where the collector current and base current are linearly increasing, active region. Here IC is independent of VC and linearly depending upon what? Beta. As beta increases, IC also increases. Now the region where the VC is very small, this region VCE is very small, approximately 0.2 volt, then this region is called saturation region. In the saturation region, both junctions are forward biased, but in cutoff region, both junctions are reverse biased. But in active region, emitter base junction is forward biased and collector base junction is reverse biased, where the transistor work as an amplifier. So we have to focus on this region. Now in this region, the collector current and base current are linearly increasing or linearly proportional. That's why this region is also called a linear region. आई होप सो जो आपको आउटपुट कैरेक्टरिस्टिक है वो बिल्कुल क्लियर हो गई होगी. ठीक है. नाउ नेक्स्ट थिंग इज व्हाट वी हैव टू फाइंड द करंट गेन एज वेल एज द एप्लीकेशन पार्ट ऑफ दिस कॉमन एमीटर कॉन्फ़िगरेशन. तो स्टार्ट करते हैं करंट गेन को. नाउ स्टार्ट करते हैं नेक्स्ट पॉइंट में, जो हमारा थर्ड पॉइंट है, दैट इज कॉल्ड करंट गेन। नाउ करंट गेन को समझाने के लिए हम लोग अगेन वही इक्वेशंस लेते हैं। सिंस IE is equals to IB plus IC and IC is equals to alpha times IE plus ICBO. Now this is equation 1 and this is equation number 2. Now put this value is IE here. So IC equals to alpha IB plus IC plus ICBO. Now just take term common, so 1 minus alpha times IC equals to alpha IB plus ICBO. Now just divide by 1 minus alpha, so alpha 1 minus alpha is IB plus 1 upon 1 minus alpha ICBO. Now the term alpha 1 minus alpha is known as beta. We will tell you in relation between the alpha beta, and this term is called 1 plus beta times ICBO. Now IC equals to beta IB plus ICEO. So you have to use this equation in case of common emitter configuration. Now if ICEO is approximately equals to 0, the common emitter when base is open, that is when base is reverse bias, then collector base junction is reverse bias, then the current existing, that is called reverse leakage current, and it is due to the thermally generated minority carriers. Then IC is equals to beta IB, then beta is what? IC upon IB. So in case of common emitter, the output is collector current and the input is what? The base current. Okay. Now we know that in the base region the base is lightly doped and thin, that's why the recombination is less, so base current is less, so beta is high. So beta is high. Now if beta is high, now if base is more lightly doped and thin, then there will be no recombination or very less recombination. Then the output current IC is very very large as compared to base current. So beta is high, beta is very very high. So alpha is greater than, beta is very very greater than alpha. क्लियर है? यहाँ तक बात समझ में आ गई होगी, होपफुली ये बात क्लियर होगी ना। बीटा की जो रेंज है दैट इज 50 to 200 एंड बीटा इज टेम्परेचर डिपेंडेंट, ठीक है यहाँ तक। सो एज टेम्परेचर इंक्रीजेस बीटा इंक्रीजेस, क्लियर है। नाउ नेक्स्ट थिंग इज व्हाट, फोर्थ पॉइंट में हम लोग समझते हैं इसका एप्लीकेशन पार्ट क्या है। फोर्थ पॉइंट में एप्लीकेशन देखते हैं। नाउ कॉमन इमीटर कॉन्फ़िगरेशन provides better current and voltage gain. So it is used as power amplifier in audio frequency range. क्लियर है? यहां तक बात समझ में आ गई होगी होपफुली। एंड कॉमन इमीटर कॉन्फ़िगरेशन is also providing the phase shift of 180 degree between input and output, because if input is this, then your output is having inverted waveform, that is providing 180 degree phase shift. क्लियर है? तो होपफुली ये कॉमन इमीटर जो कॉन्फ़िगरेशन है आपको बहुत अच्छे से समझ में आ गया होगा।